Again, Absurdity fans, that heat from that sun, I tell you what, 8 minutes and 20 seconds, it feels almost instant, doesn't it, when that sun comes out? 8 minutes and 20 seconds. Listen up, people. Let's one thing straight here. I'd rather be down at the beach than my boy, okay? These claims of the speed of light that everybody is so settled on, okay? Telling me that the age of the universe I live in, right, it's been worked out because of, in 1676, now listen to this, right, because people just keep coming back with these little, shut up, there's people out there looking for answers. No, you're not looking for answers. You've already accepted answers that there is no evidence for. This is my point. You've moved on too fast, okay? Stop. Oh, Roma. Listen up, right? How was the speed of light determined and who found it? When? How close was the estimate of 186,000 miles per second to the actual speed of light? Now, pay attention. Answer. Although Galileo was the first person of record to try to determine the speed of light, he was not successful. Of course he was not successful. 2 lamps. Why are we even talking about this? Right? His experiments took place over terrestrial distances, and the timing methods available to him were far too crude to make a successful determination given such distances and the very great speed of light. Were far too crude. There's supposed to be another O on 2. Far too crude. See these things that I notice all the time? And this got me thinking, right? Now, let's look at a storm last night. We need something, an example of something to put things into perspective, right? Because if you don't know what a billion is, and you've got nothing to compare it to, you don't know how big a billion is, right? It could be just a few more million. This is one of the first times, right, since thinking about this, that it's given me a physical mental gauge to work out something that they're saying. This 8 minutes and 20 seconds for the light of the sun to reach us, for me, it's an absurdity. The sun, she's absolute. Boom! 1.3 million kilometers at diameter. She's a monster, not 8 minutes and 20 seconds. Now, that's the moon. This is planet Earth. Can we see that? Alright? Now, last night I was looking at a storm. This light delay, 8 minutes 20 and 1.3 seconds for the light to reach from here to the moon or from the moon back here. That is at 299,792,000 kilometers per second. It's about, what, 386 on average to the moon, 386,000 kilometers. That's just over 299,000 kilometers, just over a second. They say it's 1.3 seconds for the light. Now, I was watching a storm, wasn't it, last night? Right, the lightning. Okay? Here. Now, if you were on the moon and you were looking at Earth, you know, like those fantastic pictures we get from NASA, you know, the ones that show that same picture of Earth, it's just perfect. If you were in that situation and you were looking down at planet Earth, 2 eyes, right? But one of those eyes was looking through a telescope. And the other was with the naked eye. So something like this. Right? I'm propped up, I've got something propping me up, and I'm looking at Earth through there, like that, see? you know, you get this kind of HUD display going, but I can see my car through the telescope. So I'm looking down at Earth, the storm. Now with the telescope, I am locked into Earth, right? I can see it, she's right close. When that lightning goes off, would I see it in the telescope first, and then 1.3 seconds later, would I see a little flash through with the naked eye? Or would I see them both at the same time? You think about that. That is the closest physical gauge I can think of that's not mirrors going around the planet. That is how you measure 1.3 seconds, right? At their speed of 299,792 kilometers per second. Now, does it seem logical that you'd be looking through a telescope at Earth from the moon, and the other eye, you're looking for the light, there it is. 1.3 seconds later with the naked eye? Or would you see them both at the same time? I'm telling you what would happen. You'd see them both at the same time. Common sense. Think about it. Thinking about that one, if you suss that one out, the rest of it falls to the wayside. Would you see that bolt of lightning, that flash of lightning, immediately at the same time through the telescope? Or would you see it at a different time? Would it take 1.3 seconds to get to you? You think about that. Right, and before we go on with those so ridiculousness that I can't believe I'm back on Roma. Listen, it was the Danish astronomer Olaus Rømer who in 1676 first successfully measured the speed of light. His method was based on observations of the eclipses of the moons of Jupiter by Jupiter. So we're measuring something here that they're telling us travels at 299,792 kilometers per second, and this guy is using observations of the eclipses of moons on a planet that's 740 kilometers away, million kilometers away. No, sir. Right? This is now where common sense needs to start kicking in. You don't measure something that you so fast you can't measure it. And the very first attempt was a moon 750 million kilometers away, orbiting its planet. Listen, no, common sense, yeah? There's going to come a time when you're going to have to go, whoa, hang on a minute, right? This is that time, right? Rømer noted that the observed time interval between successive eclipses of a given moon was about 7 minutes greater when the observations were carried out when the Earth in its orbit was moving away from Jupiter. Right? Now you can't just read this, listen to this, and just go, oh yeah, okay, so he did that. You've got to do it in your head. Everybody's just accepting this stuff, right? Oh, the more I go into this, the more I'm seeing. And right now, I love to know how thrust in the vacuum works. Right. That is Jupiter, believe it or not. And the one next to it is Io. We're just gonna put the sun in, not for any other reason, just so you know where things are at, right? We won't worry about how much glare that we would have got from planet Earth. We'll ignore that for now, alright? So, there, it's an orbit, right? Furthest, middle, closest, right? Just rough ballpark figure. Right, it is said, now listen, you have to listen. Not just, oh yeah, what was that? Yeah, Powers of Biscuits, Carol? Listen, absorb, right? Rømer noted that the observed time interval between successive eclipses of a given moon, successive eclipses. Alexa, how long does it take for Io to orbit Jupiter? Oh no, Sienna's taken Alexa! It takes about 42 hours. So again, Roman noted that the observed time interval between every 42-hour eclipse of Jupiter by Io. That's what that means. They make it sound like, oh yeah, there's one, yeah, there's two, no, 42 hours for one orbit. So successive, when you're saying 3 successive, you're talking 4 successive, it will take a week, all right? Well, it was faster, was 7 minutes greater when the observations were carried out when the Earth in its orbit was moving away from Jupiter, right? So the further away we got, right, the longer it was taking, right? This delay, straight away. Look, this stops right here. He was looking at Jupiter and Io through a telescope. How many times do we have to go through this? If you look at something through a telescope, you're there where it is. It doesn't matter. If he was on Pluto, right, if he's looking at Io and Jupiter through a telescope, it's always going to be the same vision. The whole orbit, the whole year that it's taken for Earth, if he's always looking through a telescope, he may as well be there. Right? Do you get that? It's ridiculous. You have to cross this off of the list. Somebody else comes back at me with Roma, it means you're obviously not paying attention, right? We need to move on from here. It's a lie. It's an absurdity, it's illogical, and it breaks down from the word go, right? So let this one go. And if you still can't understand that this is wrong, where are the PhDers? Where are the PhDers? Tell me I'm wrong. Where's all the brains? Where are all these people that keep working all this stuff out? Are they for real? Who gives the PhD? Who qualifies to then tell somebody else that they're PhD worthy? Hang on a minute. Have you ever thought about that one before? I got a PhD, okay. Who gave you that PhD? Yeah, that guy over there, he's qualified, is he? Well, how did he qualify? You need to start asking questions, right? Because I've got a very logical mind here, and it's picking up some big ones, right? So, Roma, gone, right? If you're going to still have Roma in the background, you are not going to move forward. It's dead in the water. And if you can't work that out by now, with the amount of times we've addressed this, what is there to say? You're going to be stuck where you are. It's basic common sense, what we're talking about here. It's basic common sense. A telescope looking at Jupiter and Io from anywhere in this universe, or from the angle with Jupiter forward and Io coming this way, anywhere you are. If you're looking through a telescope, there is never once going to be a single delay in any shadow, because you will always be looking at the both of them exactly as they are. It doesn't matter how far away you get from it. And that is a fact. If you can't get that fact locked in here, then they gotcha, because you don't know what a fact is. It's a lock-in. All right, I'm going to be back with Fitzo and his mirror.